Alaikum. Today we are going to solve the IAL unit for October 2022. So let's begin. The first question is, which row of the table describes the mass and the charge of the antiproton? So we know that the mass of the proton is 1.67 into 10 to the power minus 27, and the charge of the proton is 1.6 into 10 to the power minus 19. Since this is an antiproton, so therefore the option here should be B. Next one, which of the following is a valid conclusion from alpha particle scattering? An atom contains positive and negative charge distributed evenly? No, because if they are evenly distributed, then in that case we know that in the alpha particle scattering there is a large deflection. So in that case alpha particles wouldn't deflect significantly, right? So this is not correct. The nucleus of an atom contains protons and neutrons. Okay, this wasn't proved during the alpha particle scattering. Actually, neutron was discovered later in 1932. So therefore this is also not correct. The nucleus of an atom is very small compared to the size of the atom. Yes, this is right, because in the alpha particle experiment we know that it was showed that the nucleus is very tiny and dense, and most of the atoms is empty space as the alpha particle passed through the atom. So the correct answer is C. The D isn't correct as well, okay, because the atom contains a lot of empty space, not a little empty space. Question number 3, which of the following describes why electrons are released from a metal filament during a thermionic emission? Okay, so the first one, the metal filament is heated by an electric current. Okay, this is the right answer. Okay, the metal filament is heated by an electric current. Now moving to the next page, the diagram shows the shape of the electric field pattern between the two charged particles x and y. Which of the following could be the charge y? Now we can see the lines here are diverging, so that means they have similar charges, right? And they have similar charges. Now we can see this is a diverging line, so therefore the charges are minus as well. And you can see one more thing, like the region or the point where a unit charge experience almost no force is very close to the point x, like the point where there is no resultant force, that is closer to x as well. So here the option should be B, because if you consider the number of lines in x, that is half of the total number of lines of y. So therefore the option here should be B. The next one, the graph shows how the charge stored on the plates of a capacitor varies with the potential difference V across the plate. Now we know that in a charge against voltage graph, the area under the graph tells you about the energy stored, okay, so which is half into Q into V. So if you see which one matches here, so not A, B and C, the D is the answer here, because the charge here is 550 and according to the formula it should be half into Q into V, which is 12, and since this is a nanocoulomb, the charge is nanocoulomb, so you also need to multiply 10 to the power minus 9. Okay, the next one, the SI unit of magnetic flux density is Tesla. Which of the following gives the base unit of the Tesla? Now we know that what is from where do we get the Tesla, which is we are getting it from magnetic flux density. Now if we use F is equal to BQV, then we are getting magnetic flux density F is equal B is equal to F by QV, right? So if you see this carefully, then we can say from here, like since we need to get the base unit, So force is basically MA, or you can say like the base unit here is kg meter per second square, and charge q is basically IT. Charge q is IT, and I here is ampere, t is second, okay, and v is what? Meter per second square. Meter per second square, right? Sorry, meter per second. So if this is meter per second, then we can say this second will cancel out, okay. So what remains is kg, and meter will also cancel out, right? So kg ampere into kg ampere into second square. That's because here it was meter per second square, so it should go to the denominator. So eventually the final answer should be C, because this is what we get if we derive this, and the base unit here is kg ampere inverse 1 and second inverse 1. So the answer should be C. Next one. The table shows the relative charge on up and down quark. Which of the following could be the quark composition for a baryon with a charge of plus 2e? Now we know that baryon has 3 quark, right? So the answer should be either down, 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 or up, up, up. Now if we consider down, 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 then if you add all of those, okay, sorry, so if you add them, then you are getting actually minus 1 by 3, minus 1 by 3, minus 1 by 3. So you are not getting the plus 2e charge. Now if you consider up, 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 in that case 2 by 3 plus 2 by 3 plus 2 by 3, so it should be 6 by 3, which is 2. So therefore it is equal to plus 2e. So here the option should be D. Question number 8. A linear particle accelerator. It consists of a drift tube of increasing length with the potential difference applied between them. So which of the following is the reason the drift tubes are increasing in length? Option A. So the potential difference can have a constant frequency. Yeah, this is actually the right answer. Okay, this is actually the right answer, because we want the change in potential to remain constant. So as a result, in between the drift tubes we see there is a change in energy. The option B is not correct, because the particle gains energy not within the tube, it is in between the gaps of the tube, and within the tube it's a hollow tube, and it moves with a constant speed within the tube. So the B is not the answer. Number C, so that the PD between the tubes increases for each successive tube. No, we don't need to increase or decrease the PD in this case. And so the time spent in each successive tube increases. No, the time must remain constant here as well, so that as the particle is traveling, it will increase in speed in between each of the gap. So therefore the option here should be A. Next one. An object of mass m has a momentum of p and kinetic energy E. Which of the following is the mass of an object with momentum 2p and energy 2k4e? Now we know that kinetic energy is equal to p square by 2m. So since we are trying to find out the mass of an object, so we keep the mass as a subject, and we can keep p square is equal to 2ke, right? So suppose this is equation 1, and we are gonna find what is the mass of an object with a change momentum, which is 2p, and change kinetic energy for ke. So we can consider m prime is equal to 2p square divided by 2 into 4 ke. So if we keep it like this, then we can find 4p square for the disturbance. Okay. So this is 4p square divided by 4 into 2ke, right? So if you cancel 4 will cancel out, so eventually p square by 2ke is what? Is equal to m, right? So therefore we can say here m prime is equal to m, which means the answer here should be p. The last one from the MCQ part. Two coils L and M are placed next to each other. An alternative EMF is induced across coil M. Which of the following could produce this? Now we know what? We know that the voltage will be induced when there is a changing magnetic field, right? So if there is a changing magnetic field within L, the voltage will be induced in M. So what will cause the change in magnetic field? Because if you have an alternating current, so there will be a change in direction. So as the current passes through the coil of wire, a magnetic field will be induced. So since this is an alternating current, so the voltage will so since this is an alternating current, so the magnetic field will also alternate or change here, and this will cause an induced voltage in M. So therefore the option here should be number A.